All right, welcome everyone. Apparently school will be back on Thursday, but I thought I would try and do these little videos because, it's the 21st century. And I'm going to start the videos with a traditional drum roll. Good. Okay. Hopefully you can see this screen all right. And I want to pose a dilemma, I guess. And this is my dilemma. I've got three functions here. One's just a straight line, the green one. One is an exponential, and one is a logarithmic function, the black one. Excuse me. And each of these functions is increasing, right? They all go up. And when we say increasing, we mean as you move from left to right, the y values increase. Okay, so as the x values increase, or as the x values go larger, the function itself gives higher y values. Right? So we're just talking about the function itself, but I'm about to move on to the gradient as well. Right? Get rid of the straight line, and let's compare these two because they look quite different, don't they? So this exponential starts out with a gradient down here that's pretty low. It's uphill, it's a positive gradient, but maybe it's only, I don't know, like a quarter or something, but then the gradient itself increases, right? And it gives quite a different shape to this logarithmic function where the gradient down here, it's uphill, it's positive, and it's really positive. It's maybe that's a gradient of 4 or something, but then the gradient decreases. Right? It's still positive, but the gradient itself has decreased, even though the function is increasing. So here, this exponential purple function, it increases at an ever-increasing rate, whereas this one increases, but at a decreasing rate. Okay. So the dilemma is, how could we talk about these different types of increasing? Right? And the way we do it is to consider the shape of the function. Right, so if we just look at the exponential, we want to talk about how the exponential has a concave up shape to it. Right? And the easiest way to see concave up is just on a parabola. Right? Concave up. Across the whole parabola, the gradient, as you move from left to right, will increase. The gradient itself is increasing, right? As you move from left to right. This is the concave up shape. You need to memorize that. For people doing physics, you might know about concave mirrors or concave lenses, and the up could refer to your point of reference. So this, imagine a light source that's up above, going, I guess, down towards this lens. Then from that perspective, this would be a concave lens or a concave mirror. But if you're not doing physics, don't worry too much about that. If you're not doing physics, or even if you are, you can think of smiley face, sad face. So concave up is happy, I'm smiling. And concave down, again, think about it with a parabola. This is concave down. Across the whole function here, the gradient, right, decreases. Right? Not the function, the gradient of the function is decreasing the whole way across, right? And that's concave down, because when you're down, you have a sad face. Okay, thank you. That's video number 1.